P-value. P-value, or the probability value, is the measure of strength of evidence against the null hypothesis. So P-value, basically how we are going to define it, P-value is the maximum probability of rejecting the null hypothesis. It is also known as the observed P-value, because we are going to calculate this value on the basis of the observed data. So its alternative name is that observed P-value. The general rule for making the decision on the basis of the P-value is that if the observed P-value is greater than the assumed level of significance, we do not reject H0. Otherwise, we accept it. So basically, how we are going to say that अगर P-value जो है हमारी observed P-value वो हमारे level of significance जो alpha है उससे बड़ी आ जाए, तो we are going to accept H0. Otherwise, we reject it. Basically, that is the general rule of making decision on the basis of the P-value. So, यहाँ से हम एक result ड्रा कर सकते हैं. So, the smaller P-value, greater evidence against the null hypothesis, and vice versa. So, we are going to state its rule. If we given a significance level alpha, then the reject H0 if P-value is less than or equal to alpha. A result is said to be statistically significant if it allows us to reject the null hypothesis. The next step is that how we are going to calculate the P-value. So I just demonstrate a simple way how we can calculate the P-value. To test the hypothesis, that is some sort of general hypothesis that mu, I am interested in the population mean against some specified value of mu naught, which is the value related to the parameter space, versus H1, that is mu is greater than mu naught. So obviously, when we are going to test the average of the population parameter and we have a sample size is large, generally we use the Z test. And basically, the formula of the Z test, that is actually equal to x bar minus mu over sigma over under root n. Suppose after making some certain calculating the mean, and we have some specific value of mu naught, and then we calculate all these numerical computation. Let's suppose we obtain Z is equal to 2.60. That is some assumed value. You have real values when you are performing practically testing of hypothesis. Now I just only telling you how we can calculate the P-value. So P-value basically is equal to, that is the probability that Z is greater than 2.60. So if we look on the normal distribution, that is the mean in the center, and we are going to test the alternative hypothesis greater than, so which means that it is greater than mean. So this Z value is somewhere here 2.60, and here we have to find the probability, which is the P-value. So we need to use the normal tables to calculate this value. So this is basically probability Z greater than 2.60 on the normal table, and its probability is somehow this one, because you are going to calculate the probability from mean to that value, and that is actually somehow 0.4953. You can see it from the normal table, and we need this value. You know that this area, whole area, is 0.5 when we are going to discuss in the scenario of normal distribution. So that is 0.5 minus 0.4953. So it will give you 0.0047. So this is basically the P-value under this alternative hypothesis. So if suppose that I'm going to state another scenario. Let's say you have null hypothesis mu is equal to mu naught versus alternative mu is not equal to mu naught. So in this case you have two-sided this value, that is actually value minus 2.60, and this is also your p value. So in this case your p value will be probability z is less than minus 2.60 plus the probability z is greater than 2.60. Since it is a normal distribution, the value which is under minus 2.60, that is same under the 2.60. So basically that is 2 multiplied by 0.0047, and that is equal to 0.0094. So this is the p value against the alternative hypothesis when mu is not equal to mu naught.